So we're looking at the relationship between linear velocity and angular velocity. We saw that, yes, okay, let me put it this way. If I have a tire, if I have a tire, right? If this is a tire, and if it rotates, if it goes one round, it will cover certain distance. With friction and everything, if it's there, it will cover certain distance. Okay. And that's how we'll be able to relate angular with linear. If you guys have a question of how is that we are able to relate it and how can we relate it, it's quite simple. If you see a wheel, it goes round and round, but it covers linear distance. And so we'll be able to relate, and we have to relate linear velocity and angular velocity. The word linear means a motion along a straight line. Linear velocity measures how quickly an object moves from point A to point B. Now, the basic idea over here is, I have a quick question for you guys. Linear velocity in rotation is combination of angular velocity and what else? What is the other factor? What is the other factor? You guys guess it? Radius. Is it not? So if I happen to take another circle, right, a bigger circle, like which I have already over here. Right? So this is how is linear related to angle. So we're looking at that question. So the answer is, when a wheel rotates, it covers linear distance. That you guys have to write it yourself. Now, factors. So what happens if I have two tires moving with same angle, right? These are two tires with same angular speed. So both are covering one round in 1 second. 1 second, one round. But question is, who covers more distance? Who covers more distance? What does your common sense tell? Right, is it not? The bigger tire covers more distance. He is the winner. So why is the bigger tire covering? What is that? What is the variation over here? What is varying over here? Radius. And so this implies, so from this we can infer that radius plays a role. Okay, that's one more thing that we can think of. Then what else? Have the object covered the same amount of angle? Have they covered the same amount of distance? Which has covered more distance? So this is something that I had to come up with. Now, expression for angular displacement. Okay, let me take a second. Okay, now we're looking at the expression that relates angular velocity with your instantaneous linear velocity. So we're looking at that. We have a case wherein we have an object going in a circular manner and it moved from point A to point B from t is equal to 0 seconds to t is equal to t seconds, covering an angle of delta theta and covering a distance of delta s, and the radius is over here r. Now we need an expression for delta theta in terms of delta s and r. So, or let me put it this way. Delta s, can I tell that it's radius into delta theta? Right? It's common sense. If I increase this, I'll cover more distance. If I increase the angle, I'll cover more distance. The circumference will increase if I increase either of this. So is this right? And from this, can we tell therefore delta theta is equal to delta s by del r? Correct? Now, what is the expression for instantaneous angular velocity? This we already seen. Omega is equal to d theta by dt. Now, what is the expression for your instantaneous linear velocity? V is equal to d, yes, ds by dt, or whatever we want to call it as. So can you guys combine all of this? So we have delta theta is equal to delta s by r, omega is delta theta by delta t, v is delta ds by dt. Can you combine all of this? So conclusion, let me do the conclusion over here. So we know that delta theta is delta s by r. Okay, r is fixed. So now I'm dividing both sides with delta t. So d theta by dt is equal to ds by, or delta s by delta t into 1 by r. Now I'll apply the limit delta t tends to 0. Okay, I need to write the statement actually. Taking limit on both sides. Actually, taking limit is enough. So it has to be both sides. So we have delta theta by delta t is equal to 1 by r, since it's a constant. ds by dr, sorry, dt. Here r is fixed. It's not varying with time. So now what does this represent? This represent d theta by dt is equal to 1 by r ds by dt. And this is nothing but we already have written this, omega 1 by r into sv. So therefore v is equal to r times omega. So it generally, not generally, it is going back to this itself. Can you see that? So whatever we have a relationship over here, the same relationship is coming over here. Seriously guys, it's that simple. If you understand, if you use a bit of common sense, if you're able to understand this particular diagram and this expression, literally you are done with the topic. So angular stuff, people find it difficult, but if you found this easy, this very discussion easy, then it's easy. If not, you have to make it easy. You need to understand this particular expression, how I got this. Try to vary the radius. Try to vary the radius. Imagine that. Try to increase the frequency. Imagine how much it has to cover, how much it's covering, how much distance it's covering. You need to imagine. That's when it becomes simple. There's nothing that anyone can teach you. They can tell you. This is me telling it. But end of it, you need to imagine for yourself. If you're not doing that, then you won't learn. Okay. You can take a second. Imagine this. Check why is this right. Take a second. Okay. And after that, omega expression is as per the definition. V expression is as per the definition. So we can call this as 1 and 2. Right. Then this is what we know of. This is from A. We can call this as A. Okay, and then taking limits and all that, this is from 1 and 2. I'm just substituting from 1 and 2, these expressions, and a bit of rearrangement, and not from there. Here I'm applying that, and we have this expression, V is equal to omega into R. Okay, guys, so what we just saw was relating linear velocity and angular velocity. So what is it telling? The answer is telling that if I increase the speed at which this thing is rotating, I will go faster. Again, it's common sense. If your wheel rotates faster, you'll cover more distance, right? So given certain conditions, that is true. So that's what we just learned. We started with this. Then now we are over here. So that's the heading if you guys want to write. That's your heading, and everything else is left to you what you want to write over here. This mathematical derivation over here, this mathematical aspect, you guys have to write.